parametric equation, second derivative, concavity. So first of all, we have these two formula, number 1 and number 2, straight from part 1. All right, so let's take a look at the first problem. So the first problem we have, number 1, we have x equals to t squared plus 1 and y equals to t squared plus 1. So for concavity, we have to find the second derivative, and they also ask for which value of t is the curve concave up. Concave up means the second derivative is positive, and the concave up, concave down stuff is also discussed in part 1. So let's find the derivative. So dx dt is equals to 2t, right? Simple. dy dt is equals to, I wrote 1 again. So this is a 2t plus 1. And then we find the first derivative. So dy dx is equals to the dy over dt divided by dx over dt. It's not dx over dt, it's the derivative of x with respect to t. With respect means we treat t as a variable. So that is equals to 2t plus 1 divided by 2t. We can simplify that. So here is how we split up the fraction, 1 divided by 2t. So overall, that equals to 1 plus 1 divided by 2t. So that is the first derivative. And then the second derivative, that is equals to, we take the formula, we take the red formula, so that is d dt divided by dy dx, which is what we just did, and then over dx with respect to dt. So the dt, we don't know that yet, but what about the dy dt in parentheses? We take the previous part and then plug in right over there. So this one, how about this? I will just write 1 plus 2t to the negative 1, because that is easier for me to apply the simple power rule. And then dx dx, right? This is dx dt. That looks like x to me. So dx dt is from the beginning, right? So that is divided by 2t, and then the d dx of that parenthesis means you have to take the derivative of everything inside the parenthesis with respect to t. So overall, the derivative of 1 is equals to 0, and then the 2t raised to a negative 1, you can apply a chain rule. So you bring the negative 1 down, and then 2t, negative 1 minus 1, and then by chain rule, you take the derivative of the inside, right? The derivative of 2t is equal to 2. And then the denominator, no change, but since we have 2 on top and bottom, I can easily get rid of these 2. So we have the second derivative, we have negative 1 divided by 2t, the whole thing square, divided by t. So overall, that is equals to negative 1 times 4t squared divided by t. So overall, we have negative 1 over 4t to the third. So this is the second derivative. Okay, second derivative. They are looking for what? They are looking for what value of t? There is a t right there. How do you make the parametric curve concave up? So to make the parametric curve concave up, we have to make the second derivative positive, right? So what kind of t should I choose in order to make the second derivative greater than 0? Look, there is already a negative. So there is a negative built in there. So in order for the whole thing to be positive, can t be greater than 0? What if t is positive? T cannot be 0, right? When t is equals to 0, everything mess up. So when t is greater than 0, the third power of positive is still positive. So therefore, when t is equals to 0, there is no way to make the second derivative positive. So the only solution is you have to make t less than 0 in order to make the second derivative negative, so that the parametric curve is concave down. So the answer is t has to be less than 0. All right, so that is the end of this problem. Let's move on to number 2. So number 2 is right there. Don't worry about that. I will copy the problem over for you. So the next one is number 2. Number 2, we have x equals to e to the t, and then y is equals to t times e to the negative t. First of all, derivative. So the derivative of e to the t is guess what? Remember your differential calculus is still e to the t. And then the derivative of y with respect to t. So this one would be a product rule. So product rule, you have two functions. The product, take the derivative of that. That is fg prime plus gf prime. So that will be t times e to the negative t, right? And then by chain rule, the derivative of negative t is -1. So let's just put the negative in there. And then plus g is e to the negative t. The derivative of f is the derivative of t, which is equals to 1. So we have the derivative. And then the dy dt, which is the derivative of y with respect to t. Keep making this mistake, dy over dx. And then dx with respect to t. So we have a negative t e to the negative t plus e to the negative t divided by e to the t. We can definitely simplify that. So the way we do the simplification is I take the e to the negative t out, factor that out. So I have negative t plus 1 divided by e to the t. Do you still remember how the negative exponent works? E to the negative t is just 1 divided by e to the t. So therefore, the first derivative is equals to, you bring an extra e to the t to the denominator. So e to the t times itself is e to the t plus t, which is equals to e to the 2t. And then we have negative t plus 1 on top. So this one, the next part, I don't want to apply a quotient rule. So I'm trying to make my life easier. I will just do e to the negative 2t times negative t plus 1. I will use this to take the next derivative because I don't want to apply quotient rule. So the next part start with a formula, d square y and then dx square, that is equals to the derivative of t of the previous part, which is dy dx, and then we have the whole thing divided by dx dt. This is a formula straight from part 1. So if you go back to the beginning of this video, the formula is over there. The dy dt, we will just bring this part down. So that means we are taking the derivative of e to the negative 2t times negative t plus 1, and then divided by dx dt. We got that weight at the beginning. Dx dt is just e to the t. So this one gives me a product rule in there, right? So which is fg prime plus gf prime. Do the work. So we have e to the negative 2t. The derivative of the parenthesis is -1 plus, according to the product rule, g is negative t plus 1. And then f prime, the derivative of that e to the negative 2t. So you have e to the negative 2t. And then by chain rule, when you take the derivative of the exponent, that gives you -2. And then we have everything divided by e to the t. So this one, I am going to factor out e to the negative 2t. So inside the parenthesis, I have a -1. And then look, plus, okay, so I am looking at this piece. So that will be a -1 minus 2, and then plus 2t, and then divided by e to the t, and then keep working. So the second derivative, so you bring the e to the 2t to the denominator, so that, or if you don't want to bring it down, then you have actually let's just bring it down. So that will be e to the 3t, and then we have 1 minus 2, which is a -3. So you have a 2t minus 3. So they are looking for, they want the parametric curve concave up, right? So for concave up, the second derivative must be greater than 0 in order to concave up. So in order to concave up, what kind of t do I need to make this always positive? So first of all, e to the 3t, what is this called? This is an exponential function, right? So exponential function is always positive. So always positive, we don't need to consider that. To make this positive, the denominator is always positive, so forget it. So that means in order to make this positive, the numerator must be positive. So and then all you have to do is you solve this linear inequality. You add 3 on both sides and then divide both sides by 2. So t is greater than 3/2. So when t is greater than 3/2, the function is concave up. The parametric curve is concave up. All right, so that will be the end of number 2. So we still have one more problem to go. So the next one, we will move on to number 3. I'm going to switch to another color. Number 3, we have x equals to t minus ln t, and then y is equals to t plus ln t. All right, take the derivative first, dx dt. What is the derivative of ln? The derivative of ln is 1 divided by the variable, and then dy dt. So your derivative skill is coming back, right? The derivative of t is 1. Derivative of ln t is 1 divided by t, and then you have the y over the x. That will be your first derivative. So that is the derivative of y with respect to t divided by the derivative of x with respect to t. So you have 1 plus 1 divided by t over 1 minus 1 divided by t. So in this class, please don't tell me that you will cancel out the 1. If you cancel out the 1, then you don't belong to this class. So how do we simplify that? I hate complex fraction. So to simplify this, all you have to do is I am going to multiply this term by a magic 1, which is t divided by t. So basically, you will distribute the t to each member inside the parenthesis. So that equals to t plus 1 divided by t minus 1. So there you go. That is your first derivative. Okay, and then second derivative, right off the bat, we start with a formula that we discussed in part 1. So the derivative with respect to t of the previous result, or you can say the first derivative, divided by the derivative of x with respect to t. So that will be the derivative of the result, which is right here. So that will be a t plus 1 divided by a t minus 1. So this will be a quotient rule. There is no way to avoid that. And then dx dt, we got that right here. So that is 1 minus 1 divided by t. Okay, so quotient rule. You pass your differential calculus, right? What is quotient rule? Quotient rule is gf prime minus fg prime divided by g squared. Okay, so let's draw a big fraction bar. The denominator, I'm going to get a common denominator, t minus 1. All right, let's perform the quotient rule. First, I square the denominator. All right, so gf prime. So that will be numerator times the derivative of the top, which is 1 minus, according to the quotient rule, the top times the derivative of the bottom, which is 1. And then you can bring, we have a t minus 1 divided by t. What's on the top? So the top, you have t minus 1, right? So you have a t minus 1 minus t minus 1. So the t minus t is gone. And then the 1 minus 1 is equals to negative 2. So you have negative 2 divided by t minus 1 squared. So overall, what do you have? So simplify the fraction. You have the denominator will be t minus 1 to the third, and then the top, you flip this t to the top, then you have a negative 2t. So that will be your second derivative. So this is your second derivative. You want this to concave up, right? That means the second derivative, you have to set that greater than 0. Now, the top, negative 2t, is always negative, right? So that means the denominator, t minus 1 to the third power, must be negative. I want the top and bottom to be negative at the same time, so that the negative divided by negative is positive. By the way, I said the negative 2t is always negative. There is an implication. What is the implication? Negative 2, there is a negative built in there, right? You want the entire term be negative, so that means let's hold on to that right there. Let's hold on to this. So we have the denominator less than 0, but if you go back to the parametric equation, we have an ln(t), right? So we have an ln(t), and then we have an ln(t). So there is a quotient for the exponential function. So this is the graph of exponential function. For ln(t), we want the t be greater than 0. T must be greater than 0 because you need to plug in t to the ln. So when there is an ln, t must be greater than 0. So this one, there is no way to avoid this. So when t is greater than 0, what about my negative 2t? So you plug in a positive t in here, right? So that means the entire term is always negative. So we forget about this implication. So the top is always negative. The job is done. Now, in the denominator, t must be greater than 0. So t must be greater than 0. And then how do you, this one must be greater than 0. So that means t can be a 1 equal. So that means t can be 1, 2, 3, 4, 5, right? And then so on and so forth. But when t is equals to 1, 1 minus 1 to the third power is equal to 0, not less than 0. So that means for the t minus 1 to the third to be greater than 0, here is what I want. I want this quantity to be negative. Because if you take the negative, if you take the cube of that, you still get a negative. So when t minus 1 is negative, so t minus 1 is negative, so that means t must be greater than 1. So now we have t must be greater than 1 and t must be greater than 0. Can you combine them for me? Greater than 1 and greater than 0. So that means overall t must be, hold on. Why do I make this? T solve the linear inequality, t minus 1 less than 0. So that means t must be less than 1. So less than 1, greater than 0. We combine this and that. So we have one conclusion. That means t must be greater than 0. And in the meantime, less than 1. So that is how we choose the t. As long as t between 0 and 1, the parametric curve is concave up. Alright, so that will be the end of this video. We make a little minor mistake, but at the end of the day, we solve the problem anyway. So if you think my instruction is helpful, subscribe, like, and share. I will see you all in the next one. Signing out for now.